In this video, we'll be using the position function to answer some questions. We're asked to use s of t equal 1/2 gt squared plus v sub 0t plus s sub 0 to answer the following questions. Given that a ball is thrown straight down with an initial velocity of negative 22 feet per second from the top of a 220-foot building. Our first question is, what is the position function for the ball? Right? Remember that we're using this position function. Since we're working with feet and seconds, our gravity constant that we'll be using is a negative 32, and it's negative because we're throwing our ball down. Our initial velocity is given as a negative 22 feet per second, and our initial position is the top of a 220-foot building. So this is 220. So putting these constants into our position function, we have s of t equals 1/2 times a negative 32 times t squared plus, and then our initial velocity was negative 22 times t plus, and then our initial position was 220. So our position function, when we simplify, is a negative 16 t squared minus 22t plus 220. Our next question is, what is the velocity function for the ball? Remember that velocity is the derivative of position. So we need the derivative of this position function. We'll just use the power rule. Our velocity is the derivative, which is a negative 32t minus 22. Our next question, what is the average velocity on the interval from 1 second to 2 seconds? We call that average velocity is the change in position divided by the change in time. So we need to find the position at 1 second. And we're going to use our position function here. So negative 16 times 1 squared minus 22 times 1 plus 220. This gives us 182. And then we need the position at 2 seconds, which will be a negative 16 times 2 squared minus 22 times 2 plus 220, and that is 112. So our average velocity is going to be then 112 subtract 182. That's our change in position, over 2 subtract 1. This gives us a negative 70. So we would say then our average velocity is a negative 70 feet per second. Our next question, we're asked to find the instantaneous velocity when t equals 1 and when t equals 2. Remember that instantaneous velocity is the derivative of the position function, and we found that to be a negative 32t minus 22. So when t equals 1, we have v of 1 equal to a negative 32 times 1 minus 22. This is a negative 54 feet per second. And when t equals 2, v of 2 is a negative 32 times 2 minus 22, which is a negative 86 feet per second. Our next thing that we want to find is the time needed for the ball to reach the ground. Now, in order for the ball to reach the ground, that means our position is 0. So remember, our position function is s of t equals negative 16t squared minus 22t plus 220. So our position needs to be 0 for it to reach the ground. So here we have a quadratic. Let's solve that using the quadratic formula. So t would be a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. When we do the math here, we get two values for t. We have t is approximately 3.08 or a negative 4.46. Now we can't have a negative time, so we're not going to use this value, but we'll have 3.08 seconds. And then finally, find the velocity of the ball at impact. So that means we're wanting to find the velocity when t is approximately 3.08. V of that number will be a negative 32 times 3.08 minus 22. When we do the math, then the velocity at impact is approximately a negative 120.7 feet per second.